In this video, we're going to discuss the first Python project for Calculus 3, which looks at vectors and covers the material out of sections 2.1 through 2.4, up through the cross product, I believe. So let me share my screen with you and we'll get started. In the D2L Learning Management System, go ahead and go to your Python projects folder, which will be in the contents section. Now, what you want to do is you want to scroll past the Using CoCalc and Jupyter notebooks for Python, and you want to locate the submodule or subfolder called Python Project 1. There are 3 files in here. The first one is the actual program that you want to download and upload into CoCalc. The second one is a PDF of what the output should look like when you're doing basically just the examples. So this will show what it should look like. And then the last one is a link for you to upload a PDF of your document when you're done with it. So let's go ahead and download this. You can right-click here, or click on it rather on the right, and then you can choose to download it. Now, mine has already been downloaded, and you can see that down here in the lower left. So you click on download, and then it will be down here. When you get into CoCalc, you want to log in, and then you want to go to your projects. So when you click on projects, you can look at whichever one you've created, and I have one here for Calculus 3. So I'm going to click on the Calculus 3 project, and you can see I've already uploaded the file. But in order to upload one, if you haven't done it yet, you're going to click on Upload, and then you're going to navigate to the Downloads menu, and then you're going to double click on this, and that will upload the file for you. So I'll cancel that since I've already done it. Now you want to click on that particular file to start the project. I haven't been in this for a while, so it went to sleep. CoCalc will save its computing power if you're not active in the program by putting it to sleep. You have to start the project first, and then you can work in the particular file. So I've started the project, and now it's going to connect, and it's going to put me into my program. And you can see the program right here. Now, when I'm looking at this program, you'll see that it's got numbers over here. Now, none of these lines have actually been executed in this round of when I've uploaded the file. So if you want to execute a line, you can click anywhere inside of the input line, and you can hold down the Shift key and hit the Enter key. Now, when you do this, keep in mind that all of this that you see right here, from the hashtag matplotlibsets, blah, 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 to import matplotlibpyplot as PLT, all of that is considered one input line. So click anywhere inside the box, hold down the Shift key and hit Enter. Now, the first one, what it's actually doing is it's going to import the math plotting library and allow us to put things in. Now, I know that it's active because it changed the number from 2 to 1. So I know this is the most active one. Now, remember, NumPy is the numeric Python library, which allows us to multiply numbers, add, subtract, raise powers, square roots, all that sort of stuff. Anything you want to do with numbers involves numeric Python. Because we are too lazy to type in NumPy, N-U-M-P-Y, we will rename it NP for short. So when we call up all those commands, like for trig functions and stuff like that, where we actually want the number answer, we'll do np.sign or np.cosine. Now, the last command here in the first line, the first input line, is import matplotlibpyplot as PLT. Again, because we're too lazy to type pyplot, we'll rename it, give it a nickname of PLT. Now, all of this was executed and it changed this to 1, but you see there's no output line here. If it looks like an output line, you will actually see the symbol with a different color, usually a red, right here where it says out 3. So it's the output line that corresponds to input line 3. Now, you don't need to execute any of the text boxes. They're just there for you to read and understand what you're doing. So let's look at the first text box, which is addition of vectors. Let me change my share so that you can see just the file we're working on. So the first text box talks about addition of vectors. Now we know to add two vectors, you just add the corresponding components. So if you have a U1, U2, and a V1, V2, then U plus V is U1 plus V1, comma, U2 plus V2 inside angled brackets, because it's still a vector. Now, in order to enter vectors in Python, we enter them as what's called an array. Now, an array is just a list of numbers separated by commas. Now, they have to be entered in square brackets, and then that goes inside of round parentheses. So the command is np.array, so numpy. That's the numeric Python library. We're calling up an array, which is a list of numbers, and then we're giving it the two numbers. So if my vector was 1, 5, then I would have round parentheses, square bracket, 1, 5, square bracket, round parentheses, following the np.array. And you can also do one in 3-dimensional space. You just need to give 3 numbers or any dimensional space that you want. Once you have defined the arrays and named them, maybe U and V for different ones, then you can use vector addition, and you can just do U plus V, which will give you U1 plus U2 plus V1 plus V2, which gives you this U1 plus V1, U2 plus V2, which we've already learned. So let's look at what it looks like now in Python. So here's our comment. Again, we are defining the vectors. When you do this in the practice, which will be done here in this input line, you will change the names of the vectors so that you don't get them confused with the vector names I used. I'm using U and V in the example. I want you to use R, S, and T for the practice problem. So in this case, what we're going to do is we're going to define 2 different vectors. These are vectors in 2D because they only have 2 components. So the first vector U is the numpy array 1, 5, and vector V is the numpy array 7, 4. And you have to be very, very careful. It has to be typed in precisely correctly. If you mess up one bracket that's supposed to be around parentheses, it will give you a horrendous error message that's really long, and really it's just a punctuation error. So then we're going to add the vectors. So I'm going to call U plus V W. In your practice, you're going to call it T, which will be R plus S. So notice that the comments are in this sort of orangey gold color, and the actual commands are in black. That's normal. And then we want to display the result. So print, and then we have inside parentheses what I want to print. Inside the quotes, it's going to print that like a text string. So it's just going to print whatever I have. And then I have comma, and it will print the result for W. So I'm going to hold in this screen. I'm going to hold down the shift key and hit enter. It goes and it calculates, and I can tell it's calculated because it's changed the input line to 2 and the output line to 2. Now, what you need to do for practice 1 is you need to copy everything that is in input line 2, come down here, change the name of the arrays to R and S, and W change it to T, and then re-execute that line. So you're just going to copy and paste. So you're going to highlight everything in here or select all. Control C will give you copy. Then you're going to come to the blank input line and you're going to put paste. And I'll show you the first one. So you're going to change the U to R. And R in this case is 1, -3. So I can leave the first one alone, but the 5 needs to be a -3. The negative is entered as a hyphen. Now, CoCalc only uses the hyphen. It doesn't use the longer dashes that you see in Word. Always the hyphen for either negatives or subtraction. And then I want to name my other vector S. So I change V to S. And this vector is -4, 7. So I'm going to change this to -4, 7. All right. Now notice that vectors can also be given in square brackets like this. So we're using angle brackets mostly in class, but to make it print out right, I had to use square brackets. Then we want to add the vectors, and I'm going to change this from W, because if I tell it W equals U plus V, it's going to give me the answer for input line 2, not this new input line. It remembers what U and V are and what W is, and it will overwrite the result for W. So I want this to be T, and I don't want to add U and V. I want to add R, and I want to add S. And then down here, I'm not printing out W anymore. I'm now printing out T. So I change that to T equals, and I tell it to print T. If you don't change that, it'll say T equals, but it'll give you the value for W. Now you've changed everything in here, so you're going to hold down the Shift key and you're going to get Enter, and you'll notice that it has renamed the input line 3 and given the output for 3. Okay, so from now on, I will not do the practice problems for you, but I will go through and explain what each part of this makes sense. All right, so let's take a look at different things. So in this particular one, and I can see they've changed something in Matplotlib 3.5. So I probably need to change something. So we'll change it on the fly while we're doing this right here. So plot the vectors U red, V blue, U plus V green. In practice 2, replace U with R, V with S, and W with T, just like we did previously. Now here, we're plotting vectors. If we're going to plot the vector, we have to tell it where to start plotting and where to stop. So we have to give the initial point and the terminal point. And this is done with a command called plot quiver. Quiver kind of meaning, well, you know, the quiver is what holds the arrows. So what we do is we list all the starting X values for every vector I want to plot in these square brackets separated by commas. Then I give all the starting Y values in order. So the first X value goes with the first Y value. And if I had Z values, those would go next. And then I'm going to give the X components, which would be the terminal point. So this is where it's going to end. Again, in order, so you've got to match them up. First one goes with the first vector, second the second vector, third the third vector, and so on. And then we have to tell it to show the graph, which I always find this is really funny. You tell it all these commands with plotting, but if you don't type in plt.show with empty parentheses, it won't show the graph, which I think is hilarious. Okay, so coming down here, it looks like they have changed the name of the B parameter in grid. So right here, we're going to highlight this, and we're going to rename it visible, V-I-S-I-B-L-E. So we're going to change that to visible, which hopefully will be in your file when you look at it. Now let's go ahead and interpret what we're doing. We want to plot our vectors. So I'm going to plot U, V, and W. So U and V, and then I added them together and got W. And I want to verify that this works. So I have PLT quiver. So PLT is a plotting command. Quiver is going to give me all the vectors. So again, it kind of makes sense. The quiver is what holds the arrows. I'm telling it all the arrows that I have. So this first set of brackets right here is going to be, so let me click, make sure you can see my cursor. The first set of brackets is all the X values. The second of brackets is all the Y values. The third one gives me the ending X components, and the fourth one gives me the ending Y components. So the first is the initial points for X, initial points for Y, terminal points for X, terminal points for Y. And then color, I named them red, blue, and green. You could name them different colors. I don't remember all the color commands. I know M is magenta. I think there's an aqua color, but I can't remember what the shortcut for it is. And then angles XY, just make sure that we're getting the XY graph, and scale is 1. So what is this going to do? it's going to take the first coordinate from the quiver for the first set of square brackets. That's 0. Now go to the next one, and the first one is 0. So the first vector's initial point is 0, 0. Where is the first vector's terminal point? Well, we come over here and we see that's at U0, U1. So we've got it starting at 0, 0 and going to the end point of the U vector. So U0 is the first component inside the U vector, and the U vector was coming back up here, 1, 5. So U0 is the 1 and U1 is the 5. So it's ending at 1, 5. So it starts at the origin and ends at 1, 5. Now the second vector that we want to draw starts at the end point of where we just stopped. So it's going to start at 1, 5, which is U0, U1, and then it's going to go to the end of W, rather the end of V. So we're going to draw the end of the V vector. So V0 is the X component of the V vector, V1 is the Y component of the V vector. And then we want to draw one more vector, which is U plus V, or W. So again, we're going to start at the origin. So X is 0, Y is 0, 1 each from the first set, 2 sets of square brackets. And then we want to end at W0, W1. W0 is the X coordinate of the W vector. W1 is the Y coordinate of the W vector. So 8 and 9. W0 is 8. W1 is 9. So it's very common in Python and in programming in general to start counting at 0 instead of starting at 1. So you'll often see it's starting with W0, W1. Okay, so that will give us this plot. Now we have to set the size of our screen. So basically, how much of the XY plane do you want to see? So I know the values that I have up here for my U, V, and W go between 1 and 8 for X and 4 and 9 for Y. But to make it kind of in the center, so it's not right up against the side, I decided to plot X from -2 to 10 and Y from -2 to 10. So that kind of gives me a nice square screen. And then I'm going to want the grid lines to show up, and this needs to be changed in the original file, so I'll change it for you. The B has been changed to visible, which makes more sense. And this just means, yes, I want to see the grid lines. And which equals major, I'm not sure what that does. And then we have to tell it to show the plot. Now it hasn't executed left yet, so I'm going to hold down the Shift key and hit the Enter key, and it's thinking, and then it plots it for me. And you'll notice that that error message about the B for the visible disappeared. And so it's not there anymore, all right? And you can see now that we've got the U vector here to 1, 5, and then we plotted on the end of that the V vector, and the V vector was 7, 4. So again, that's going to be going to the right 7 and up 4. And that gave us, in fact, the W vector, which you can see right here using the triangle method of adding vectors. Now, for practice 2, what I want you to do is I want you to come in here to input 4, copy all of this down, and change all the U's to R's, all the V's to S's, and all the W's to T, which means you're going to have to change all the commands in the plot quiver command. Now, this is just an extra line here. So how do you get rid of a line if you don't want a line? This is a blank line of comment. You can come up here to edit, and there is something that says delete cells. Now, if you delete something you didn't want to delete, you can then do a Control-Z, which will put it back in, and you can see it's now gone. And you have the empty space for you to practice what you learned in the previous section with practice 2. Now let's look at scalar multiplication. So we have vectors here. Define the vectors. In practice 3, You will again rename U, R, V as S. And now we have a three-dimensional vector. So U is now 152. This is going to overwrite what U used to be. And from this point forward, it will think U is a three-dimensional vector 152. And we're going to have V be 741. And we want to compute W, a new vector, as 3 times U minus 2 times V. Notice that in the programming, it does not understand implicit multiplication. If you type 3U, it will give you an error message saying it doesn't understand. You have to make the multiplication explicit by using the asterisk symbol. 2 asterisks makes it a power. 1 asterisk is multiplication. So I have my vectors defined, and then I print it out. What goes inside the quotes prints as is, as a string. And then I want it to print W. So I'm going to hold down the Shift key and hit Enter, and I get the same value I got last time I did it. Now you're going to practice this particular input line, input 5, by copying the whole thing and pasting it here, but you're going to change the array for U to R and from 152 to 1-30, change V to S and make it -475. And then I want you to calculate 1/2 S plus 5R. Now, for 1/2, you can do 1 and then use the diagonal slash, the / at the bottom of the keyboard next to the Shift key, and then 2, and then an asterisk and S. It does follow the order of operations. So it would take 1 divided by 2 and multiply the result by S, which is what you want. The other thing you can do is you can use parentheses around it, round parentheses, 1/2, close parentheses, asterisk S. That gives you multiplication by S, plus 5 asterisk R. Make sure that you make the multiplication explicit. Let's take a look at the next section, which is the dot product. So when we talk about how do you do a dot product in a computer program, it's actually already defined. We don't actually have to program it to do the dot product. It has a command for the dot product. We just have to call that command up. And it is a NumPy command, so we'll use np period dot. I was going to say np dot dot, but that doesn't make sense. So again, the command is going to be right here. You can see the np dot dot. And then, as all commands have, we have round parentheses with the components of the command on the inside. We want to dot 2 vectors, U and V, and that will give us np dot U times V. So give us the dot product of U and V, which will probably give a name, and I'll probably call it W again or something like that. Now, the magnitude of a vector U, you know that you use the double bars for the magnitude of a vector, is the square root of each component squared added together, right? Now, there is a command for that, and it's called linear algebra normalizing. So normalizing also, well, I won't get into the historic reasons, but this is the command to give the length of the vector U. So np.linalg.norm, and then in parentheses, the vector you want the magnitude of. So we also will want to call up the inverse cosine function. Now, again, we want a number answer, so we're using the numeric Python library. If we wanted it in terms of symbols, we'd have to use the symbolic Python library, SymPy. So now what we want to do is we're going to call up whatever we have. So the normal way of seeing arguments is np, that tells it go to the numeric Python library, call up the one you want. Ours is going to be called, I believe, arc cosine. And then we'll tell it whatever it is we want it to take the arc cosine of. Now, the default is radians, not degrees. So keep that in mind, which is good for us because our default is also radians. Now, when you practice this, you can redefine U as P, V as Q. All right, so we're going to use different vector names this time. Could you use R and S? Yes, of course you could. But I just gave you new names so that it wouldn't change the vectors. So now we have two vectors, u and v, np.array. Remember, array is just a list of numbers. That's all it is. And the first one's 1, 2, 3, and the second one's -7, 8, 9. We want to compute the dot product. So I actually gave it a name that makes sense, and I called it u.v. All right, now you can call it something different if you want to, but u.v tells me what I have. So equals np dot dot round parentheses u comma v round parentheses. Now I have to display the result by telling it to print, and I want it to print out exactly u.v equals, and then to give the value of u.v. Now we want to find the angle that's between u and v. So in order to find the angle that's between u and v, we need to find the magnitude of vector u and the magnitude of vector v. So we use the np.linalg.norm command, linear algebra, normalizing the vector. It sometimes gives you the magnitude of it. And so we have u underscore mod, right? And v underscore mod. I can't remember exactly why I called the mod. You could say it u underscore mag, v underscore mag for magnitude. That works as well. And then we want to print magnitude of u is comma u mod, and magnitude of v is v underscore mod. So, or mag, you could call them either one, right? So if you want to change those names up here, you can definitely do that. Just make sure you change it in both locations. All right, and then this is going to give us the magnitude, but now we need the angle. So remember that the cosine of the angle is the dot product of two divided by the magnitude of each one. So that is going to give us u.v divided by, and notice I use parentheses here to force it to do the multiplication first, and then divide the dot product by that product. And the parentheses are necessary, otherwise it divides by u mod and multiplies the result by v mod, which puts v mod in the numerator. So now what I'm going to do, and this gives me cosine of the angle, so I named it cosine underscore angle, so this gives me cosine of the angle. Then to get the angle, I call up the arc cosine command, np.arccosine of cosine angle. Then I wanted to convert it to degrees just so I could kind of tell what was going on. And you'll notice that I've got this string of two divisions here. Now, I can either do it this way, following the order of operations, or I could put parentheses around the 2 and the np.pi and multiply the two together. So either one is okay. So angle in degrees, take the angle, which is right now in radians, multiplied by 360 degrees divided by 2. That gives me a result, and I need to divide that by pi, because really I need to divide 360 by 2 pi. So again, you can either do it in this order, which follows strict order of operations, or we can put parentheses around the 2. Notice it makes that parentheses red because I don't have a closing one. Put the closing one here, it makes them both green, and it shows you which one it matches to. And then I need to take out the division because I'm multiplying these two together first. And then this just prints out what the angle in degrees is. Hold down the shift key and hit enter, and you get the dot product is 36. The magnitude of u is about 3.7. The magnitude of v is almost 14. And the angle between the two in degrees is 46 degrees. Now, could I also get the angle in radians? Yes, I could. If I wanted the angle in radians, then I would need to tell it to print angle degrees, all right? Or angle rather, not angle degrees. So I could print that as well, right? So let me show you what that would look like. So I can come up here and I can type print. Now I have that. I want one set of quotes. Notice it opens both up and it says the angle between u and v in radians is, and then I want to go to the end of that quote, put a comma, and I call this angle. right? And down here, I may want to add in degrees, be a little more specific, and now I need to re-execute that line. So I'll hold the shift key and hit print. And now you can see that it's 0.8 radians, which is about 46.3 degrees. Now I want you to repeat everything in this input line, which is now 7, in the practice number 4, but with P and Q. So you'll need to change all the U's to P's and all the V's to Q's and change the name of U mod and V mod and make them U magnitude and, or P magnitude and Q magnitude, all right? And make sure you change the names inside of the print commands as well. A lot of detailed work. Now we want to look at a vector projection. So in the vector projection, remember that the vector projection is a vector and it's the projection of V onto U. So you've got this vector V and a vector U, and V casts a shadow along U, all right? So we find it by taking the dot product of U and V and then dividing by the magnitude of the vector it's projected on top of, multiplied by that vector again. So in this case, we're going to again set up 2 different vectors. So I have U and V, and in this case, I did 2-dimensional. They could be 3-dimensional. I will need the magnitude of the vector I'm projecting onto, which in this case, I want to calculate the projection of V onto U. So I need the magnitude of U. So I use the np.linearalgebra norm command to get the magnitude of U. And then I set W, which is my projection, to be the dot product of U and V, np.dot parentheses UV parentheses, divided by U mod, which is the magnitude of U. And notice I have 2 asterisks, which gives the power raised to the power of 2. Close that parentheses and then times U. Now I can calculate Q, which is V minus W, and then I want to print the projection of V on U is W, and Q equals V minus W, which equals, and then print out Q. So I've got the projection of V on U, and then I've got Q, because remember the projection plus the vector Q gives me back the vector V, right? And I need to change something down here, the B visible. So instead of, when I plot the grid, if instead of saying B equals true, I'm going to make it visible equals true, all right? And now I'm ready to go through. I'm going to plot different vectors. This is going to start at the origin, all right, for the first one. And it's going to plot U. So U0, U1, that's the X component and Y component of U. The second vector, look at the second positions. So the X component is 0, the Y component is 0. So starting at the origin again, plot vector V, which is V1 or V0, V1. And then the third vector, I'm going to start at the origin again, 0, 0. And then I'm going to plot W0, W1. And remember, W is that projection, all right? And actually, W is not a great name. So you could call it projection, but you got to be careful because projection is also a command inside of Python. So, and it might get kind of long, so I called it W. And then I want to go and I want to plot Q. Q starts at the end of the projection. So instead of starting at the origin, I want to start at the end of the projection, which the X component is W0 and the Y component is W1. And then I want to plot Q, which will go in at Q0, Q1. And I made them red, blue, green, and magenta. And this time I made it a square graph plot axis, and then I gave the command for square. I went -2 to 10, -2 to 10. You may need to change the X limit and Y limit. And now I want to execute. So I hold the shift and hit enter. It takes that error command away. And now I have 2.8, 3.6, and so forth. And you can see that I've got the vector V, and I've got the vector U in red, and then I've got the projection of the blue onto the red is green, and the vector Q is magenta right here. So when it gives the colors, it gives them in order, right? Now you're going to practice this with two different vectors, and you're going to produce a plot, so you should be able to see that. We have one last example to do, which is the cross product. And the cross product, like the dot product, is already defined inside of Python. So we need to set up our vectors. So we have NP, and let's see what. So we have our two arrays, which are our vectors, 1, 2, 3, -1, 2, -1. We want to calculate the cross product. So to calculate the cross product, we use the numpy command np.cross of U and V, and that will give us the cross product, and we'll call that W. So W equals, and we give W. Now we want to use the cross product in order to find the size of the angle between the two vectors U and V. Now these are in 3D. So again, remember that the cross product is the magnitude of each vector multiplied together times the sine of the angle in between. So we can use that formula to find the angle by computing the arc sine of the magnitude of U cross V divided by the magnitude of U and the magnitude of V. And that will give us the magnitude of U cross V. So we compute the magnitude of U using the linalg.norm command, the magnitude of V, again with the same command, and the magnitude of the cross product with the same command. And we want to print all three of those out so we know what they are. Then we set the sine of the angle to be that size of the W, which is the cross product, divided by the magnitude of U and the magnitude of V multiplied together first. So, and then we have angle will be the arc sine of that angle. And then we convert it again into degrees. So I want to add a command in here that will print out the angle in radians. So I'm going to add in parentheses, and then we'll have the angle in radians between U and V is, and then after the quote, we'll have a comma, and then we'll have angle, right? And I want to execute the command, so Shift Enter, and I get everything that you see down here. And you see again that the magnitude of U is about 3.75, magnitude of V is about 2.5, the magnitude of the cross product is about 9, a little bit more. And the angle between them is 1.57 in radians, which is exactly 90 degrees. So we know that the angle between U and V is that. And then you're going to take everything inside of this particular input section in this entire square or rectangle, and you're going to copy it, and then you're going to paste down here, and you're going to change all U's to P's and all V's to Q's, and give it a name for your cross product. I don't know what you want to use. You can't use X or Y, so you might call it W2 or something like that. And then I want you to do exactly the same thing again, but with those particular vectors. So I hope this helps you in your first Python project and explains what all of the commands mean and what they're doing. We'll have more of these videos as we continue through the semester.